Would you believe night lights for pampered soybeans? Would you believe nostalgia in the cornfield, reviving the plant forms of yesteryear? Would you believe wild oats sown by doctors of agronomy? Would you believe sorghumizing corn to confound the pesky rootworms? Would you believe people who coddle their pedigreed corn borers and go to great bother to protect them from harm? Who insist on infesting their own cornfields with their own highly bred borers? You can believe it, all of it, and most likely benefit from some of it in time, because these are just a few of the odd ventures ag scientists are involved in, here at the Iowa station and at other ag experiment stations throughout the country. They wage the battle of the borer in strange and wondrous ways. They breed superb borers with the exquisite care of the dedicated animal breeder. They protect their broods from borer diseases and enemies with incomparable diligence and create carefully controlled environments, the better for borers to thrive in. In a normal year, they harvest a crop of 1¼ million egg masses, each of which will produce 30 or 40 pedigreed larvae, blue ribbon blackheads, superior specimens of the borer breeder's art and skill. With some of the egg masses, they artificially infest various corn breeding plots, infest them thoroughly and uniformly with scientific care. Then they observe and evaluate the results. The infested corn is itself as consummately bred as the borers. The plots contain different experimental varieties that the corn breeders have engineered genetically, plants that are literally programmed for specific experimental purposes. One primary research goal is to upgrade the level of resistance to first brood borer damage. Another major goal is to ascertain the nature of the chemical factors involved in second brood resistance and develop inbreds that are resistant to second brood borer attack. They wage the battle of the borer in odd and imaginative ways. They've determined that the corn borer mating process operates purely by chemical attraction, and they've identified and synthesized the sex attractant compound. They've also determined that the mating chemistry is susceptible to interference, and they've discovered compounds that are potent inhibitors of the mate-finding process. The idea is to control the corn borer population with chemical countermeasures that destroy mating communications. Another idea is to use moth traps, baited with the sex attractant to determine the onset of a breeding period in a locality. Farmers in the vicinity could be forewarned to anticipate a maximum larvae hatch in a given number of days, and could take preventive action at the optimum time. And perhaps that preventive action will be foaming action one of these days. The ag scientists are developing the use of foam as a carrier for insecticide application and exploring the advantages of foaming over other methods. As in the never-ending battle of the borer, so too in the perpetual war on the worms. The corn rootworm has rapidly adapted to each new chemical designed to kill it. So the corn breeders are looking for ways to breed rootworm resistance into the plant itself. One such venture involves finding some way to sorghumize the corn plant. The sorghum genus is fairly close akin to the corn genus in the family of cereal grasses. Yet sorghum roots are immune to corn rootworm. Is there a genetic character in sorghum that wards off the rootworm? A sliver of a chromosome? Or a gene or two, perhaps? A resistance mechanism that, if it could be bred into corn, it'd be free from rootworm? Will the corn breeders win this way-out war they're waging on the worm? Nobody knows. But they've got a pretty good track record for bringing home some mighty long shots. In corn, the main and most persistent enemies are the borer and the rootworm. In the small grains, the major and perpetual enemies are the various kinds of rust, particularly in oats. Rust mutates rapidly to adapt itself to attack each new rust-resistant oat variety that's developed. And wind-borne rust spores can sweep from the Carolinas and Texas clear up into Canada's prairies in a few days. So the grain breeders have come up with a remarkable new battle tactic. They've developed new multi-line oat varieties, in which each line contains different genes that are resistant to different strains of rust, while all are alike in looks and yield. Since these new multi-line oat varieties present a broad spectrum of resistance, no one rust strain can devastate a crop. It can infect only a mere fraction of the total plant population. This technique has far-reaching implications. Can it be applied to the other small grains? The grain breeders are exploring this new genetic frontier. In yet another exotic project, the ag scientists are literally sowing wild oats to develop high-protein adapted oat varieties. Our present adapted oats are about 16% protein. Wild oats are double that. Through careful genetic manipulation, the oat breeders are preserving the high-protein character of wild oats while getting rid of the junk, the bad characters. Already they've developed adapted oat varieties that produce 25% protein and more, while also retaining the multi-line rust-resistant characters. Be it multi-line, protein-rich oats, or multi-eared or prolific corn, the grain breeders keep moving on all fronts. Multi-eared corn was the normal thing before the 1900s. But as farms grew ever larger, the trend went to one easy-to-pick ear. Today, mechanical harvesters have erased the advantage of one-eared corn. So the corn breeders are developing new prolific hybrids. Prolific types have been used for a number of years in the South. The main advantage of the prolifics is their superior ability to adjust to the stress effects of drought and high plant population. In favorable conditions, they produce 2 harvestable ears. In stress conditions, they produce at least 1 ear. The prolifics bid fair to become the corn of tomorrow. Another new look in corn for tomorrow may well be the upright leaf or funnel types that corn breeders are investigating. The goal is total utilization of sunlight for greater yield. Upright leaves allow maximum light penetration into the plant canopy. What's more, upright leaf corn can be planted at higher populations and in narrower rows and still intercept maximum sunshine. One single cross upright leaf variety has already been reported to yield 40% more grain while showing 50% less barrenness than its flat-leafed counterpart in tests at another university. Another study in light utilization involves night lighting, using low-intensity electric light at timed intervals. Yes, they undertake odd ventures and work in wondrous ways here at the Iowa station and at its counterparts throughout the country. And they're all growing one crop that offers by far the greatest promise of all. The upcoming ag scientists for tomorrow. The bright new breed on whom we can rely to generate the ever further advances in farming's future.